Welcome back, AI enthusiasts. In our first two sessions, we laid the groundwork, understanding artificial intelligence as a broad field, and then diving deep into machine learning, the powerful way AI learns from data. Today, we're taking the next big leap into the most revolutionary subset of machine learning, deep learning. What we'll explore today. Get ready, because in this session, we're going to uncover the magic behind deep learning. Specifically, we'll cover the definition and key characteristics that set deep learning apart, understanding the power of artificial neural networks, or ANNs, the fundamental building blocks of deep learning, why deep learning has seen such a massive surge in popularity recently, exploring some of its most impactful real-world applications, and finally, a glimpse into the future trends that deep learning is shaping. By the end of this session, you'll not only understand what deep learning is, but also why it's at the forefront of AI innovation. What is deep learning? Let's start with the fundamental question. What is deep learning? As we briefly touched upon, deep learning is a subset of machine learning that utilizes artificial neural networks, or ANNs, with multiple layers to learn from vast amounts of data. The deep in deep learning refers to the number of layers in these networks. Traditional machine learning models often have one or two hidden layers, but deep learning models can have tens, hundreds, or even thousands of layers. This depth allows them to learn more complex and abstract representations of the data. Think of it like this. If traditional ML is like understanding simple sentences, deep learning is like comprehending an entire novel, extracting nuanced meaning from every chapter and paragraph. The power of artificial neural networks. At the heart of deep learning are artificial neural networks, or ANNs, inspired by the structure and function of the human brain. Neurons, or nodes. ANNs are composed of interconnected neurons, or nodes, organized into layers. Each neuron receives inputs, processes them, and then passes an output to other neurons. Layers. Input layer. This is where your raw data enters the network. Hidden layers. These are the deep layers where the magic happens. Each hidden layer learns increasingly complex features from the data. For example, in an image, the first hidden layer might detect edges, the next might combine edges into shapes, and subsequent layers might recognize more abstract features like eyes or noses. Output layer. This layer produces the final prediction or classification. Connections and weights. Neurons in one layer are connected to neurons in the next. Each connection has a weight which determines the strength and direction of the signal. Learning through adjustment. During training, the network adjusts these weights based on the data it receives and the errors it makes. It's an iterative process where the network constantly refines its understanding of the patterns in the data. This is how the network learns. The power of these deep, layered structures lies in their ability to automatically learn hierarchical features directly from raw data, eliminating the need for manual feature engineering that is often required in traditional ML. Why the deep learning boom? So, if neural networks have been around for decades, why has deep learning only exploded in popularity in recent years? Three main factors are responsible. Big data. We now have access to unprecedented amounts of data. Deep learning models thrive on huge data sets, as more data allows them to learn more intricate patterns and generalize better. Computational power. The rise of powerful graphics processing units, or GPUs, originally designed for gaming, proved to be incredibly efficient at performing the parallel computations required for training large neural networks. This made training complex deep learning models feasible. Algorithmic advancements. Significant breakthroughs in algorithms, such as new activation functions, optimization techniques, and novel network architectures like convolutional neural networks and recurrent neural networks, made it easier to train deeper networks effectively and overcome previous limitations. These three factors, data, compute, and algorithms, created the perfect storm for deep learning to truly flourish. Real-world applications of deep learning. Deep learning is powering many of the most impressive AI applications we see today. Computer vision, image recognition, identifying objects, faces, and even emotions in images and videos. Think of facial recognition on your phone or in security systems. Medical imaging analysts, assisting doctors in detecting tumors or anomalies in X-rays, MRIs, and CT scans with high accuracy. Self-driving cars, enabling vehicles to see and understand their surroundings, recognizing pedestrians, traffic lights, and other vehicles. Natural language processing, or NLP, machine translation, powering services like Google Translate, providing increasingly fluent and contextually accurate translations between languages. Speech recognition, converting spoken words into text, as seen in virtual assistants like Siri and Alexa. Chatbots and conversational AI, creating more human-like interactions with AI agents, from customer service bots to creative writing assistants. Generative AI, content creation, generating realistic images, videos, music, and even text based on simple prompts. This includes technologies like DALL-E, Midjourney, and ChatGPT. Drug discovery, accelerating the discovery of new drugs and therapies by simulating molecular interactions and predicting drug efficacy. The impact of deep learning is truly transformative, pushing the boundaries of what AI can achieve across virtually every industry. Future trends in deep learning. Deep learning is a rapidly evolving field, and the future promises even more exciting developments. Ethical AI and explainability. As deep learning models become more complex, there's a growing focus on making them more transparent and understandable or explainable AI, and ensuring that they are developed and used ethically, addressing biases and fairness. Edge AI, deploying deep learning models directly onto devices like smartphones, smart cameras, and IoT sensors, rather than relying solely on cloud computing. This enables faster processing, better privacy, and reduced latency. Reinforcement learning with deep learning. The combination of these two powerful paradigms is driving advancements in areas like complex game playing, robotics, and intelligent control systems. Foundation models and AGI. The development of massive foundation models like GPT-4 that can perform a wide range of tasks and adapt to new ones, bringing us closer to the vision of artificial general intelligence, or AGI, AI that can understand, learn, and apply knowledge across a wide range of tasks, much like a human. The journey of deep learning is far from over, and its potential is still being fully realized. What's next and conclusion? And that brings us to the end of our deep dive into deep learning. You now understand its core components, why it's so impactful, and the incredible applications it's driving. In our next session, we'll shift gears from theory to practice. We'll start exploring the crucial first step in any AI project: data preparation and pre-processing. Get ready to get your hands a little dirty with data. I hope this session has ignited your passion for deep learning. Your thoughts and questions are always welcome. Please leave a comment below. If you found this video valuable, a like and subscribe would be greatly appreciated to support the channel and ensure you don't miss future lessons. Deep learning is ML with multi-layered ANNs. ANNs learn hierarchical features through weighted connections. Boom due to big data, GPUs, and algorithms. Powers vision, NLP, generative AI, and more. Future: ethics, edge AI, deep RL, and foundation models. Thank you so much for joining me today. I can't wait to see you in the next session as we tackle the world of data.